Guys, in this video, I want to show you an example using the integration by parts formula. We already discovered or kind of derived that formula and I have it right here. Guys, again, I like to use this formula. If you are like already using another formula from your textbooks or from other places, that's fine. Keep using that, but give this a try and see if you like this or if this works out well for you. So in order to evaluate this integral, again, the substitution method is not going to work. Any direct formula thing is not going to work. There's no shortcut to doing this. So one has to use what is called the integration by parts method, where we see there's a product of two functions. Guys, in this case, we have the product of a linear function or an algebraic function and a trig function. So we already know, like, when we have a product of two functions and we want to use the integration by parts form, we want to like first follow this the fact that we should start with the inverse and then logs and then the algebraic and trig and then exponential. So obviously here it's dealing with algebraic and trig functions, so we want to use algebraic first and then trig next. They're already in the right order, so the first thing what I'm going to do is I'm going to just label this as f and this as g. Okay, guys, if it was written as cosine x times x, it would still be the same function, but then we had to still rearrange it so that we label or we start with the right f and right g. Once you label the right f and right g based on this, right? Based on this, so if I have to do it, if I have to do anything with integration by parts, first I'm going to write this for my reference, and then I will, once I have it in front of me, then I'm going to look at my actual problem and then I'm going to decide which is my f and which is my g, which is exactly what we just did. Once I have it, then I'm going to look at my formula and I'm just going to rewrite the right hand side of the formula. In this case, it is going to be f, right? I'm just rewriting the right hand side by just substituting the values. Okay, so f is just simply x in times integral of g of x. So g is cosine x dx, just replacing the values for f and g. Not too complicated, guys. It's still very easy. So we're starting with a simple example, but the process is just going to be the same. You just have to use first you have to start with rewriting this and decide which function to choose as f and as g, and then apply the formula. And then this is f prime. Well, we don't have to write extra steps for that. F prime is the derivative of x. Derivative of x we know is 1. So it is 1 times then integral of g of x is cosine x dx. And then there's another dx all the way at the end. Okay, that is step number 1, or you can think of that as step number 2, 1 being like deciding which is f and which is g. Then let us move on and simplify. So x times integral of cosine, we know integral of cosine is sine x. That is already done now here. And then this is integral of 1 times. So 1 times that quantity is not going to change that quantity. So it's basically integral of this. But again, integral of cosine is just simply sine x, and then there's this dx. Okay, that goes right here. I think we are almost there. So it's x sine x minus integral of sine x, guys, is negative cosine x. So it's going to be negative cosine x. And then there's, of course, a plus c. Don't forget that plus c, it is an indefinite integral. And then let us see if we can simplify further. It seems like we can. Just negative times negative is positive, so it's positive cosine x. And then there's a plus c. Guys, this is the antiderivative of this product function. We use the idea of including, starting with algebraic function as our first choice for f. And then for g, we use the trig function, use the product rule, and we figured out the final integral. So guys, again, figure it out for yourselves whether you want to use this formula or the other formula that you see in your textbooks, and then try to solve these or find the integrals of these products. Okay, so I will see you guys in the next video with another example on the product formula. There's so many different types, and I will try to show you many different types, as many as we can. And then guys, if you have any questions for this section or in general for evaluating integrals of different types, feel free to reach out to me through my YouTube channel, and I would love to actually get back to you and give you some hints or solve some of these problems up here as well. Okay guys, take care. I will see you